degrees and turning points for polynomial functions. Our objective for this video, identify the relationship between degrees and turning points of polynomial functions. So there is a relationship between the degree of the polynomial, a fifth degree, a fourth degree, etc., and how many turning points it can have. So what do we know here? Coming into this is going to help us. Well, we know what a polynomial function is. A function of the form f of x equals coefficient times x to a power plus coefficient times x to a power, etc., etc. And this is the constant term here. And when our powers of x's are written in order from greatest to least, we call that standard form. And we want to note that when they're written in order from least to greatest, the largest exponent or the highest power is called the function's degree. And we also know that polynomial functions of degree 2, which we also call quadratics or higher, have graphs that are smooth and continuous. Okay, we saw that a few videos back. So let's take a look here. The graph of f of x is equal to x to the fifth minus 6x cubed plus 8x plus 1. And we want to note this is in standard form. Okay, so we know it's a fifth degree polynomial, and that graph is shown right here below. Okay, note that the graph has 4 smooth turning points. Let me slip this up a little bit so we can see that a bit more clearly. Okay, just a second. Let me get my work out of the way. There we go. I think that's pretty good. Okay, so here's the graph of x to the fifth minus 6x cubed plus 8x plus 1. And this graph, well, we know the end behavior, it's an odd degree in the leading term. So it's going to have opposite ends. It's a positive 1 coefficient. So as I go to the left, it decreases. As I go to the right, it increases. And in this case, in the middle, I have 1, 2, 3, 4 turning points. Okay, so I'm increasing and then decreasing at this turning point. I'm decreasing, then increasing at this turning point, etc., etc. Okay, so that's how that works. And let's talk about what this will show us, or how these two things are related. A polynomial function of degree n will have at most n minus 1 turning points. In other words, the maximum number of turning points is 1 less than the function's degree. So this polynomial example here is a fifth degree polynomial. It turns out that this particular function has 4 turning points, and that's the maximum number. Okay, it could have 3. A fifth degree polynomial could have 3 turning points, could have 2 turning points, could have 1 turning point. Okay, it could have no turning points, but the maximum number of turning points is going to be 4, 1 less than the degree. So note the words at most. A fourth degree polynomial, for example, can have fewer than 3 turning points. Let's take a look at 2 graphs, x to the fourth and x to the fourth plus 3x cubed. Notice this is a fourth degree polynomial. This is also a fourth degree polynomial. So I'll come into here, and I'm going to graph y equals x to the fourth. X to the fourth. There it is. And let's go to my zoom and standard. Okay, and you'll see with this graph here, there's just 1 turning point. It's right there. Okay, it can have at most 3. It turns out this one has just 1. If we want to zoom in, go to my window, I'll go between -3 and 3 on the x-axis and between -1 and 1 on the y-axis. And you can see here coming in, it flattens out there, but that is 1 turning point for this fourth degree polynomial. Let's take a look at our other example, which was x to the fourth plus 3x cubed. And I'm going to go back to my Zoom 6 standard, and here we have it. And you'll note this one. Okay, well this one, it turns out, has one turning point. Right here, it turns from, it's decreasing, and then it increases. Here, it's not a turning point, it's increasing, and then it zeroes out, then it's increasing. It's not turning here, going from increasing to decreasing. It's just kind of flattening out. So here's an example of a fourth degree polynomial that has one turning point. So again, the words at most. A fourth degree polynomial can have at most 3 turning points, but it could have 2 or it could have 1. Okay, so recap. If you have a polynomial of degree n, and it has at most n minus 1 fewer turning points than the degree.